Okay, so we left off working on the second number line, quote unquote. Now we're going to put those two things together to make our graph. So we know we're going to look at the f prime part now. This is what we need down at the bottom. So we know it starts out below the x-axis until -2. So up until that point, we also know that it's increasing. So it's below the x-axis here, it starts there, and at -2 is where it crosses, okay? And then it's still going to continue to increase until 0.8, and then it turns to decrease. Okay, so that's this part. Now it's above the x-axis from -2 to 3.3, and that is true. Okay, and then from 3.3 it's below the x-axis, and it's also going to continue to decrease. So there's our graph. And now a little note about this point right here. We know the x value is 0.8 because that was our point of inflection for over here. To find that y value, we don't know yet how to do that, but that's where your second derivative, so that's g double prime, that's where it equals 0, so where it crosses the x-axis, which we do not know yet, so don't worry about it. You're just going to estimate the y value. Your answers could vary on this point, so it could be like up here, it could be down here, as long as your x value is at 0.8. And then let's just fill in these blanks really fast. This was telling us kind of how to do it. Part A says to mark the number line above to show the values where g of x changes from increasing to decreasing. At these x values, the slope of the curve is 0. Okay, and then on the function, we refer to those values as extrema or max and min values. So we've already talked about that, and you can read those. It kind of gives you another explanation of what everything means. Moving on to the next page. Answers will vary on this. It says we just want to identify some specific characteristics for the three graphs. So starting out at f of x here, and then we'll look at the f prime and f double prime. We're not going to compare them as far as what it means from f of x to f prime of x, but we're just going to look at the characteristics between the three. Okay, so f of x, we can see that it's increasing on all intervals, that it starts at -3 and it increases forever. So that's what this first one is. And then the second one, this is concave down because it opens down. It's not like a drastic opening down, but it is concave down. And all of the slopes on this line are positive. So those are three things that we can identify. Again, answers could vary if we weren't doing this together. We're just identifying just a couple things that we can see. All right, so for this one over here, the obvious things are that it's decreasing from -infinity to 2, okay, and that it increases from 2 to +infinity. And that's really all we need to know. Let me see it. On this third one, we can see that it increases first to this point right here, which is our max, and that looks like it's about -2.5. So it increases to -2.5, and then it also increases from 0 to +2.5-ish. Okay, so that's a couple things that we can see. The second things are decreasing, so it decreases from -2.5 to 0, and then again from 2.5 to +infinity. So that would be another thing that we could see on this graph. Okay, and the last thing, they've noted the concavity here. It's concave down, concave up, concave down. And then they just wrote that it's concave up from -1 to 1 because those are the points of inflection right there. Okay, so those are just a few characteristics that we can see. We're not connecting them with any meaning yet. All right, so these are the derivatives of those graphs. So the first one, we can see that now it's all above the x-axis. So the derivative is greater than 0, it's positive, it's above the x-axis. We can also see that's decreasing now on all the intervals from -3 to infinity. And then instead of having positive slopes, this one only has negative slopes. So you can see that at any point, if you drew a tangent line at any point on this graph, they would have a negative slope. Okay, so over here in this one, this is the derivative of our absolute value function from above. This one is below the x-axis, or negative, or less than 0, however you want to say it, from negative infinity to 2. And it's also a constant value, so it stays the same, it doesn't fluctuate. So that's what they have written here. And then from 2 to infinity, it's above the x-axis, it's greater than 0, it's positive, and it's also still a constant value. It's a straight line, it stays the same. Okay, so for the third one, one of the things they saw, or they noted, that we can see is that it's above the x-axis, where f increases. So I guess they are going to compare this up here. So where f increases, so from negative infinity to about -2, I guess, -2.5, I think is what we said. Yeah. That also is where it's above the x-axis. So again, it increased from 0 to 2.5, we said. And so from 0 to 2.5, it's also above the x-axis. So that's one thing to note. And then same thing where f prime is below the x-axis, that's where f was decreasing. So from -2.5 to 0, that's where it was decreasing. We can see that here. And from 2.5 to positive infinity, it also decreased there. So that's one way to keep it relevant. And then our last one, f prime, where it is 0. Where f prime is 0, so at, let's see, -2.5 and 0, actually that's our point of inflection, so I don't know that one. Yeah, -2.5 and 0 and 2.5. Those are where we have max and mins on f. So -2.5, 0, and 2.5. Okay, so they tricked me. I didn't think we were going to compare them, but on those we did. Okay, so this one, f double prime, it's just all below the x-axis. That's all they really have for that one. And then f double prime of the second one, it's equal to 0 everywhere. So it's a straight line at 0, except for 2, because that's where we had our holes up here. And also you can see at 2, that's where that sharp corner was. So that's where the holes are here. All right, and for the third one, f double prime equals 0, where f prime equals 0. So there are x-intercepts at negative, well, can't really tell what that is, -1 and +1, maybe a little more. And that's where f prime was 0. They had their max and mins right here and right here. So it was like 1.5 or something. Sorry, Campbell was banging her stroller into the floor. Okay, and then f double prime is 0, where f of prime has a point of inflection. So at -2, well, I keep saying that, but it's like -1.5 and 1.5 or something. Where f double prime equals 0, f prime has a point of inflection. So, the point of inflection is here. Sorry, at 0. And that is where f prime is 0. That was my bad. Okay, so moving on. This, it's okay. I know I can already imagine your all's faces of confusion right now. And it's fine. It'll get better, I think. This page was just strange. I don't know why they threw it in here. But I think the last example and then the part that I'm going to have you write on the back of this, I think that'll help a lot. Okay, so last page. There is a very good relationship that will help you kind of determine what their behaviors are doing with their functions and the derivatives. This table is not a good explanation of how that works, but I will have you go ahead and copy this down just how it is. So pause the video and do that. And I'm going to No, Campbell. I'm going to explain kind of what this means. And we're going to write it in words on the back of the paper here in just a little bit. So where f of x increases or decreases, hold on. Okay, sorry about that, guys. So where f of x increases or decreases, that has a direct correlation with where f prime is positive or negative, where it's above or below. And then where f of x is concave up or concave down, that's where f prime increases or decreases. This is also where f of x is concave up or down, where f double prime is positive or negative. And then if we look at where f prime is increasing or decreasing, that's where f double prime is positive or negative. So, like I said, this will make a lot more sense when we write it in words here in a few minutes, after we do example 6, which I also might have to make a third video, or I might just post it up here and let you copy it down. Okay, so sketch f of x given f prime. So now we are given the derivative and we're asked to work backwards. So this looks like a lot, but we still have our two number lines. Okay, the first number line is where we're going to look at increasing and decreasing and above or below. So we're looking at f prime where it's above or below the x-axis. So f prime starts out above it, and I made these little pink dots for the x-intercepts for f prime so we can kind of keep that in check. So here they are in our number line. We don't have actual numbers, so that's why I just made them pink dots. Okay, so it's above the x-axis, so it's positive here. Then it goes below, and then it goes back above, so that's in between these two. And then from here to here, it's below again, and then it's above again. Okay, so what does that mean for the graph of f? Well, in between these pink dots, when it's above, that means f is increasing. Okay, below f is decreasing, and then increasing, decreasing, increasing. And if we look up here, where this is positive and negative, where f of x is positive and negative, that tells us where f of x is increasing and decreasing. Alright, so now we want to know if these are going to be maxes or mins at these points. And if it goes from increasing and it turns to decreasing, that's obviously a max. So this one will be a min, max, min. And you can take a few more minutes to kind of pause and figure that out. But I only have about 2 minutes left on this video already. Alright, so f prime, down here we're going to look at where it's increasing and decreasing, and that's going to tell us the concavity. So we started out here, positive and negative. Now we're going to look at here where it's increasing and decreasing, and that one is going to show us what the concavity looks like for the function. So f prime starts out decreasing, so it goes down to this green point, so I labeled those green. So it's decreasing first at that green point, and then it turns and increases between those two, decreases, increases. So pause this video as you need to and look at that. Okay, now this tells us about concavity, which we already looked at from that chart. So when it's decreasing, it's concave down, concave up, concave down, concave up. That just means it's opening down and up. Alright, so now I did put a couple notes down here that the x-intercepts of f prime are the max and mins of f. So wherever you see the pink dots on our f prime, that's where our max and mins are going to be for f. And then the max and mins of f prime are the points of inflection for f. So the green dots are going to be the points of inflection, where it changes concavity. Okay, so if we put all of this together, we know it increases until the first pink dot, which is our first max value. Then it decreases until our second pink dot, which is our new min value. It increases and decreases and increases. We also need to make sure that we're checking the concavity. So it's concave down in between, well, from negative infinity to that first green dot, and then like so on. Okay, so make sure you're pausing this and checking it, and I'm going to switch to the next page, and that'll be the end. Crap. Here it is. Okay. This is the end. Make sure you read through this and write this down on the back. Alright, message me with questions.